Welcome back to Math Concepts. In this video, we are going to discuss the idea of a subset. Okay, so remember, the reason that we are looking at set theory is to give us an example of a mathematical structure that is different from the structure of arithmetic, that's different from the number system. Okay, now when I say structure, I mean a collection of objects, and in set theory our objects are sets, along with operations we can do on these sets and relationships between the objects. So we've already discussed one of the set operations, and that was finding the complement of a set. And in this video, we are going to discuss the idea of the subset relationship. That's a relationship between sets. So we are going to switch over to the document camera and look at some examples of subsets. Okay, so we're working through section 2.2 of our textbook. And in the previous video, we discussed the idea of the complement of a set, and in this video we're going to discuss ideas about subsets. So this is what we're doing now. So after this video is through, you should be able to determine if one set is a subset of another, and you should be able to count how many subsets a given set will have. So let me go to my next page here. Okay, so we say that A is a subset of B, and it's written this way. Okay, you'll notice that kind of looks like the less than or equal to symbol from arithmetic. It's a little bit rounded at the end. Okay, so we say A is a subset of B if every element of A is also an element of B. So what I want to do here is do a couple of quick examples of looking at two sets and saying whether they are a subset or not. Okay, so if they are a subset, we're going to write this symbol between them. If they're not, we'll write the one with a slash. Okay, so in this first example, we see on the left 1, 2, 3. Those are all elements of the set on the right. The set on the right does have some additional stuff, but every element here is also an element over there, so we do have a subset. All right. Now in example 2, you'll notice, okay, yes, this set is smaller. This set has cardinality 2. Over here we have cardinality 6, but there's more to the subset relationship than just having smaller cardinality. Okay, you'll notice this set has the letter G, but that does not belong over here. So this is not a subset. So our reason is G isn't an element of that set. A, B, C, D, E, F. Okay, so if we ever are trying to convince somebody that one set isn't a subset of another one, all we have to do is take an element in our left-hand set that doesn't belong to our right-hand set. Okay, now here I've got two special sets. W, you'll remember from our earlier videos, stands for the set of whole numbers, and N stands for the set of natural numbers. And my claim here is that W is not a subset of N. And that's because 0 is an element of W, but 0 is not an element of the natural numbers. Okay, so we have an element over here that does not belong over here, so not a subset. This one's a kind of a funny one. We remember this symbol, it's called the empty set. Okay, this actually is a subset. The reason is that for me to show the empty set isn't a subset, I have to take something in the empty set that doesn't belong over here. But the empty set doesn't have any elements. So the empty set can't not be a subset. So it is a subset. Okay? So for any set A, the empty set is a subset of A. That's an example of something that is called vacuously true. This statement is true because you can't prove it's false. Okay. I also wanted to talk about how to count the number of subsets a given set will have. So let me do an example first. Okay. I'm going to define my set capital A to be A, B, and C. And I want to list all possible subsets of the set A. So when I'm thinking of constructing a subset of A, I'm going to go step by step and consider each element. If I'm making a subset of A, do I want to put little a in there? Yes or no? Okay, if I decide yes, my subset is now looking like this. If I decide no, now my set is still empty. Okay, now my next decision to make is, do I want to put the element B in my subset? And that is a yes or no decision. So if I decided to put A in and then I decide to put B in, my subset will look like this. If I decide not to, my subset will just contain A by itself. If I had gone this route and left A out and then decided to put B in, I would have just B. But I could have gone this route and then decide not to put B in, so my subset is still empty. Okay, now my last decision to make is, do I want to include the element C? So let's examine what happens. If I've gone through here, in other words, I've included A, and then I've included B, and then I include C in my subset, I will have all three elements. If I decide not to include C, then I'll just have A and B. If I go this route, where I've included A, said no to B, and then say yes to C, I would have this. And if I decide not to put C in, then I would just have A. Okay, now on this branch, I've said no to A, yes to B. If I say yes to C, I've got this. If I say no, I'm here. And we'll finish it off like that. Okay, so we can see here we have 8 subsets, and I've got them all listed here in this very systematic way of deciding whether or not to include each individual element. Now, we typically won't need to do this every time. There's a shortcut to doing this, so let me show you the shortcut. Okay, let's say this is my set. It's got 5 elements in it. Okay, so I have a 5-step process for building a subset. Do I include the number 1? Yes or no? I have 2 choices. Do I include this? 2 choices. Because that's, once again, a yes or no decision. In fact, every decision will be a yes or no decision as to include an element or not. You have 2 choices at each step. There's a very shorthand way to write that, in fact, right? 2 times 2 times 2 times 2 times 2, 2 to the 5th power. So 32 subsets for this set. All right? So a very quick way to determine how many sets, or sorry, how many subsets a given set will have. You look at the cardinality of your set, and you take 2 to that power. So since this set has cardinality 5, it's going to have 2 power 5 subsets. Oh, one last thing. We say a subset is proper if it is strictly smaller. You'll notice here, when I listed out the subsets, one of the subsets was the set itself. So this is not a proper subset. So this has 8 subsets, 7 of them are proper. This set right here has 32 subsets, 31 proper subsets. So if you can find the total number of subsets a given set has, you just subtract 1 and that'll tell you the number of proper subsets. Alright, so the key concepts from this video were how to determine whether one set is a subset of another. Okay, so make sure you understand how to do that. There will be homework questions about it. There will be quiz questions about determining whether or not one set is a subset of another. And number 2 is be able to tell me how many subsets a given set has. And there's a very quick way to do that. You take the cardinality of your set and you take 2 to that power, and that'll be the number of subsets your set has. Okay, so we're going to go ahead and move on to 2.3 in the next video. We'll put a link to the next video down here, and we're going to continue our work in math concepts.